We are Team 22, and we will be presenting on our analysis and redesign for a gas grill assembly. So our gas grill is going to be used for outdoor grilling, and it comes with an attached side table to store food, as well as a platform to hold a propane tank. There are about 20 million grills sold in the US per year, with the primary customer being retail and wholesale stores, and a small amount of direct-to-user sales. And the secondary customer is going to be the individual using the grill who bought it from those retail or wholesale stores. Here is the CAD model of our full assembly, and here's the CAD model for our exploded view. We did choose to exclude nuts and bolts from the next few steps due to the number of parts, but we did use a strategy that would allow us to reduce the number of nuts and bolts used. We also considered the burners and tank to be supplied by a third party.
Then for the fast diagram we have the task function of cook food, with the primal basic function of heat air by enabling ignition, supply gas, by conducting the gas and storage the gas. The secondary function is to support food by offering surface. Then the support functions are to prevent burns by maintaining fire control, provide handling surface, and closing heat. Then we have to resist corrosion, assist cleaning, heat temperature control, easy storage but allow transition, reduce noise, and having temperature display. Then for assembly sequence 1, we will have a focus from bottom to the top of the grill. We will have a total of 6 pre-assembly, and the customs are 2 at the beginning, the end cap and the wheel, and the tank, plank wood, and side table are at the end of the assembly. Then for assembly sequence 2 we have a focus on the lower grill, that is the biggest component that offers major support for the other parts. We still having 6 pre-assembly, but we are moving the tank, the side table board, the wheel, the plank wood at the end of the line.
Now that we have both of our assembly sequences, we can compare them on this table. Sequence 2 is clearly an improvement, as it has optimized ease of locating parts and has also optimized ease of fastening and joining parts. Moving on to the function component mapping matrix. As you can see, each part of the grill corresponds to a minimum of one function, so there are no unnecessary parts. However, no function requires more than 3 parts either, which is good because that is less than the 40% cutoff where you would have to redesign and grow a part. The exception is corrosion resistance and other support, which are non-specific and can't be expected to follow that rule.
So here is the bill of materials for the grill. Similar grill models online have been sold for around $400 to $500. The estimated cost of this grill from our analysis falls between 50 and 70% of the retail price at around $271.
This is our quad chart classification where we base on the BOM and the total cost for each part. For high cost and functional importance, we have the main components of the grill that will be the center of the assembly, like the burner plate, cook grate, upper cover, lower grill, and support legs. The functional differentiation table we separate for a high-end and regular model, with the functions of store gas, provide handling surfaces, easy storage and handling, allow translation, and reduce noise. To make the componentity table, we separate the modules that will be used on the high-end grill with the side table and burner, the axle, the wheels, the end caps, and the gas tank.
As part of product family design, here we show the CAD model for the Supreme line for the primary customer and the premium version for the secondary customer that has additional items to improve the experience with the product. Both versions of the product had common interfaces, such as wheel and legs, the additional burner or the table, as well as the gas tank and the noise rubber protector. For the product family assembly diagram for the original sequence, we can observe the variation of the product starting on assembly step 3 and 4, highlighted in green, that leads into a product proliferation very early in the process. Finally, after analysis the assembly process and moving the premium items later into the sequence, we were able to keep a product commonality up to step number 9, as shown on the improved product family assembly process below.